Good morning, everybody. I welcome you to this morning's session. Glad we have a full house. Pretty tough to miss a Monday morning session. Maybe a Thursday morning, but not a Monday morning. This is going to be scaling to new heights with my colleagues from Coinbase. My name is Rob Martel, and I'm a principal engineer as a cloud resilience engineer at AWS PRO303.
I'm Dr. Adam Link. I'm an engineering manager at Coinbase, and I lead our Cloud Center of Excellence.
And hello, my name is PRO303, and I am a senior staff software engineer, part of Coinbase's Cloud Center of Excellence.
So what we're going to do this morning over the next 45 minutes is walk through a journey that we professional services and our colleagues at Coinbase went through for the last 18 months. And it's a 10-time scale program. Particularly, we tried to lay out a program that would drive towards three very, very important business objectives. The first was reducing cost. And sometimes when you add scale and reducing costs, they don't quite always fit together. But one of the large objectives was to close and reduce the amount of costs that they had in the current infrastructure. The second thing, as you can imagine with Coinbase, they wanted to be able to scale. And the 10 times means they wanted to be able to drive their architecture to support 10 times the amount of traffic or the potential traffic that they had today. And lastly, they wanted to modernize their compute infrastructure. And that meant move from that older EC2 architecture to a more state-of-the-art Kubernetes-based architecture. Did anybody here walk to this facility at the Mandalay Bay? I did. Well, if you did, you know it's a really, really non-straight journey. So in this particular case, the journey, which was going to last about a year and a half, was not going to be a straight journey. There's going to be roadblocks. There are going to be things that you're going to have to overcome. There's things you're going to have to backtrack, much like the walk to this particular facility. So what were those sorts of things? Well, how do you make EC2 clusters more reliable? How do you go through an incredibly highly scalable system and make it even more scalable for traffic that was really unpredictable? How to drain traffic? You can scale infinitely, but you also don't want to carry that cost. So how do you draw that traffic? When that traffic goes away, how do you draw down those resources? How do you use static stability? So we talk about static stability in AWS, but everything can't be static. So you can have ultimate scale and static, but you also drive costs up. So again, remember those sort of three pillars that we're trying to achieve. One is scale, one is reliability, and one is cost, and balancing all three of those to meet all of the business objectives. Lastly, on the EKS design, move to EKS, yes, but what are those new designs that are really going to allow them to do all three of those things? And are there better tools? Do we have to reinvent tools? Do we have to create custom tools? So all those questions and roadblocks came along in those 18 months, and my two colleagues here over the next 40 minutes are going to describe that journey.
Perfect. All right. Well, thank you, Rob. Quick show of hands here. Who here is a Coinbase user? Okay, let's get a hands up. Okay, perfect. Well, that's great. So a lot of the audience already kind of knows what Coinbase is. But for those of you who are not yet Coinbase users, let me just kind of go through a brief overview of our company and the particular technical challenges that we face that are unique to our industry. So Coinbase was founded in May of 2012. So we've been around for quite some time. We've been through multiple, obviously, crypto booms and busts. We are the first and only publicly traded cryptocurrency exchange. We actually take a lot of pride in this. We work with our auditors and with our regulators to ensure that we are compliant with relevant US and international laws. And we are in the crypto space. So for those of you who've been watching cryptocurrencies, right, they go up, they go down. There's been wild swings in this market. And this sudden volatility causes traffic influxes in our systems. So we actually note a couple of things in our systems when like Bitcoin goes up, right? We need to ensure that we are scalable going up, and we need to make sure that we are staying up. There's a meme that we finally broke that when Bitcoin goes up, Coinbase goes down. Bitcoin recently went up, Coinbase stayed up. It was a huge win for our systems and a huge win for us as engineers. We also need to then make sure that during bear cycles, right, when the prices go down, when there's less interest in crypto or crypto winters, we need to bring our infrastructure back down to ensure that we are serving trades profitably, right, because we are a business. And so it's the scale of our infrastructure going up and down that we really need to pay attention to as cloud engineers. And just to give you guys a sense of the influx we have, If any of you have ever worked for a gaming company or have seen a day one launch of a game, the engineers are scaling systems behind the scenes before that launch happens. In crypto, it's almost as if we were launching a new game, but no one told us when the launch date was, right? So how do you manage that influx of traffic?
So now we're in 2022. Like the rest of the crypto industry, we're coming out of a bull cycle where we saw massive adoption across the board. As a result, the whole industry had to do a sort of reset to the new normal. We knew we were about to go into a new bear cycle where our efficiency was going to be tested. As a result, we launched a variety of cost optimization parallel work streams to help us get there. And we'll be covering some of those in this presentation.
All right, so let me talk about the CCOE role at Coinbase. For those of you who are not familiar with CCOE, it stands for Cloud Center of Excellence. And really what our job is inside of Coinbase is to ensure that we are using the cloud properly. So when we say the cloud, we don't just mean AWS, we mean any basically SaaS vendor that we use, any cloud vendor that we use. We really look at how do we use the cloud effectively and efficiently. We have three main pillars on the CCOE. The first of these is Cloud Architecture Excellence. This basically means, are we building it the right way? There are many ways to build things in the cloud. Each individual cloud has its own particular ways of building, and we want to make sure that we are building correctly for that particular software, right? And so when we look at AWS, we are building, how do we build on top of AWS's excellent offerings? Second thing we look at is cloud usage excellence. So not only are we building the right thing, but are we using the right things, right? And we want to make sure that we are using the right things cost efficiently and completely. So you can think about this that, for instance, it's less efficient to run a CPU at 2% than 90%. Right? And so we look at these ways of saying, okay, how can we build the right thing but keep costs down as we're building the right thing? The third pillar we look at is cloud lifecycle management. Here at reInvent, we're going to hear about all sorts of new things that AWS is launching. And that's great news, unless you already have existing workloads, because now you have to figure out how to transition those workloads from the old architecture that is no longer the best, or the old version that is no longer the latest. And how do you do that at scale without taking a company down? And that's the third pillar that we look at is, how do we get from here to here efficiently and not impact our customers? When we as the CCOE look at what we do, we think of it as cloud optimization is really a function of the expense of the cloud workloads we're running divided by the rates we're paying for that architecture. And in that way, we can control costs either with a better architecture or with better rates. For the managers in the room, I'm a manager. These 4 bullet points should look pretty similar to a lot of managers here because these are the dichotomous constraints that we face. So the first problem we have is how do we scale for traffic surges without over-provisioning? We can certainly keep our systems running at a low usage and ensure that we never go down. But we would be bleeding money and not able to stay in business, right? That's a business problem. How do we become cost optimized without sacrificing resiliency, right? For the folks who are managers and techies in the room, right? You've got 3 databases, 2 of them are readers, 1's a writer. How do you save costs? You take out the readers, but you just decreased your resiliency. The next thing is how do you maximize your system use without crashing during scaling? So for instance, if you run your CPU at 90%, right, you are definitely maximizing your system utilization. But when you have an increase in traffic coming in, you are already redlining that box, and there's a high likelihood that you're going to actually top out your resources in a single box before you can bring up a new node. And the last thing, again, managers, how do you get it all done faster with fewer people? And this is certainly something that we had a problem with at Coinbase as well. How do you drive massive change without a sudden increase and basically taking all these savings you're getting and spending it on headcount? Okay, so as we go through the presentation today, we're going to have this slide repeated throughout the presentation to give everyone a sense of where we are on our journey. There are 3 distinct phases that we took on our journey, and we'll talk about each phase individually. Each phase also had its own statement of work. We'll talk about what that is and how AWS Professional Services ties in. What we would do internally at Coinbase is take a look at where we wanted to go in the next stage and understand our learnings from the previous stage, as a way to make the next stage incrementally better. So with that, let's go into the first stage here. So the first stage of our migrations that we'll be talking about today is going from EC2 x86 to EC2 Graviton. For those of you who are not familiar with what x86 and Graviton are, these are basically compute architectures. They are different ways of running code on a box. And x86 and Graviton are not cross-compatible. So we had to start looking at how do we make that switch from EC2 x86 to Graviton. Now, before we get in a little bit to how AWS Professional Services helped us with this, I want T to talk a little bit about what we did internally at Coinbase before we brought in professional services.
So one of the things that we had to do is we were running on auto-scaling groups prior to our EKS migration. So we needed to improve the scaling process, so we analyzed that holistically. On the left-hand side of the chart, you can see time until identification of a scaling event necessity. That means how long will an auto-scaling group take to know it actually needs to scale out. Then on the right, you have time until newly launched servers are bootstrapped and begin taking on traffic. Once you launch that host, how long will it take before it actually starts serving your customers' traffic? So we looked at this, and I remember when I first started working on this problem, we had a monolithic style service that was Ruby-based. It would take about 15 minutes to scale out and start serving traffic. That is not what we need, especially in a volatile market, so we had to implement some updates to our infrastructure. So what did we do? Well, we actually first started working with adding the ability of warm pools into our infrastructure. Warm pools is a feature from auto-scaling groups where it'll actually allow your host to come online and serve traffic faster. I'm not going to get into technical details of how or why it works the way it does, but just note this was important for us, and we achieved a lot of scalability, increased scalability due to that implementation. Next was step scaling policies. Prior to this, we were just using target tracking, which is a feature from auto-scaling group. You may not notice, but target tracking is just inherently slow. It needs free data points before it makes a decision on if to scale out and how much. In our environment, that is too slow. We need to react as quickly as possible to changes in traffic. So we added step scaling policies. And those are made to work together with target tracking, where target tracking deals with the gradual changes in scale up and scale down. And the step scaling policies deal with the sudden surges that we see for our services. And finally, we needed to add more granular metrics. This is where we're going to improve the left side of that chart that I mentioned beforehand. We were able, with some configuration changes, to get down to a minute, but we knew we needed more granularity. So I worked with our observability team to enable 10-second granularity for our metrics, and then update our step scaling policies to work with that in tandem with the target tracking. So once we did this, the results were we actually were able to enable sub-minute scaling for our services, which is extremely important during these volatile times. And one thing to call out is the sub-minute scaling was specific for Golang services. We just had better responses from these changes. But now that monolithic style service that I just mentioned previously, that would take about 15 minutes. With these updates, we were able to get it down to 3.5 minutes. Drastic difference that really helped our bottom line. So with all of these updates added to our infrastructure, I started working with all the teams across Coinbase to implement them. And we were able to achieve massive savings across the board by just adding a new couple configuration changes that we had just enabled. So not only were we able to increase our cost efficiency, but with these changes, we're able to improve our scalability and reliability, because that's the most important part. We always want to be up and serving customers. Now Link is going to cover our EC2 to Graviton migration that occurred after these infrastructure changes were implemented.
Thanks, T. All right, so we needed to reduce our EC2 spend during a bear market, right? We had a crypto winter that happened. And we realized that one of the easy ways of reducing EC2 spend is by paying less for EC2. Graviton has a 20% cheaper list price on EC2. So what did we do? Well, we said, well, let's go ahead and switch from x86 to Graviton, right? It's a cheaper list price, and so obviously we're going to save money. But we had to do this in a way that we fanned out throughout the entire organization. Coinbase is a big company. We have a lot of services that we run. So the problem was, how do we take this newfound knowledge that the CCOE and T had worked on and fan it out across multiple teams very quickly? Our solution was actually to bring in AWS professional services. So you'll see SOW on the slides. It stands for Statement of Work. And what we basically did was talk to our AWS team, our technical account manager, and say, hey, we need help with fanning out across our organization and doing these repeatable steps with each service, kind of tailored for each service. What can you guys do? And AWS said, well, we have this professional services group that we can bring in to help. So we worked with AWS Professional Services to craft our first statement of work, which outlined the work that they would do to help us migrate from x86 to Graviton. So the concrete action here for those who are looking to take something away is, if you're looking for professional services, that first step is reaching out to your technical account manager. We allocated our budget for AWS Professional Services based on the expected savings we were going to see. So what we basically said is, okay, we're going to save 20% on EC2. That's X number of dollars. If we can get professional services for cheaper than that, that is a net positive ROI to the company. And that was something that our finance team agreed with.
Okay, so why did we decide to go with Graviton? Well, it's a 20% cost savings instance for instance, so that's a good reason. But furthermore, we actually had better performance and a reduced carbon footprint, which is great for everyone. But now we ran into an issue. When we started implementing this into our legacy build pipeline, we initially were using emulated builds. So we were essentially emulating the Graviton environment within an x86 host. The problem with that is we actually end up resulting in 2xing our build times. And that is important. We can't have that occur because otherwise no one is going to want to adopt this new architecture. So we worked together with our professional services team and we re-architected our pipeline and switched it to the batch build pipeline that you see on the right-hand side. We have an x86 host create the artifacts for x86-based instances, and a Graviton host create one for the Graviton-based instances. Then final step, just combine them and push them to ECR. The end result of that is we're actually able to keep the build times the same for all migrated services, thus ensuring that our customer experience for our teams was better. So what were some of the learnings from this? Well, as I mentioned, customer experience matters. Imagine I had gone to every team in Coinbase and said, hey, we have this great architecture that'll save you money, but you'll have to wait twice as long for builds to occur. No one's going to accept it. No one's going to adopt it. So you need to make sure that you put them in a better place, or at the very least, the same exact place they were beforehand. Next, instance availability is extremely important. So when we're doing this migration, this was around the early ages of Graviton, so there wasn't the best availability. And we have some pretty large services running at Coinbase that we just could not afford to have any issues or get iced, essentially unable to grab a new instance. So that actually prevented us from launching larger services on Graviton. The warm pools feature that we had recently started using, which helped improve our scalability by a very large amount, you cannot have multiple instance types attached to the auto-scaling group. That was a limitation from the auto-scaling group team at that point in time. I know they're working on it, but I haven't heard if they actually released anything related to it. But either way, that was a limitation for us, so we weren't able to fully adopt Graviton during this phase as a result. Next was Golang versus Ruby. We initially actually worked on both languages because we used to be a Ruby shop and now we're a Golang shop. But we still had services that were Ruby-based, so we attempted this Graviton migration on those as well. One thing we found is that Ruby-based services needed to be on the 7th gen Graviton-based host, so M7G instead of M6G, to have this better latency than x86. So as a result of that, we just weren't really able to onboard more Ruby-based services over to Graviton. And finally, as a result of this, the Cloud Center of Excellence team was slowly building out the best practices for working with AWS Professional Services. I can't really mention how many times I've been reached out to by other Coinbase teams that just wanted to replicate our success with their goals as well. So now we've gotten to the end of the partial migration to Graviton because we couldn't migrate everything over. What were some of the results of that? Well, with Graviton, you can actually have a higher sustained utilization for your host while not impacting latency nearly as much. Then, with the batch build process, it actually helped improve our customer experience. And as a result of these two things, we saw a reduction in resources used. Next is cost. As I've mentioned, Graviton-based hosts have about a 20% cost savings. So we're able to achieve a reduction in spend that way. And finally, resiliency. As a result of these migrations, we did see some improved latency for our services, and also better instance variety, since you can now go x86 or Graviton instances. As a result, we had happy customers and happy regulators, which is very important. Next, you're going to hear Link talk about phase 2, our EC2 to EKS migration.
Thanks, T. Okay, so we realized that Graviton was an effective way to reduce our spend on EC2, which we needed to, right? Again, because we were in a bear market. But we then started looking for other ways that we could increase efficiency, right, while also using the cloud better. And we said, well, we're not on Kubernetes yet. So what if we switched from EC2 to EKS? Now, for those of you who don't know, prior to running EKS, we basically ran a one service, one host setup, right? So no matter how big your service was, you got an EC2 node. Obviously, EKS, no matter how big your service is, you can put it into a pod. You can put multiple pods on a single node. So let me talk through a little bit of the problems and solutions we had with that phase. So what we needed to deliver was a way to shrink our compute cost by 50% or more. This is a huge number, right? How can we become more optimized using our compute? And again, being better stewards of the cloud and actually using what we are architecting. Our problem, of course, though, is the cost to deliver. So again, this is an orchestration layer change across an entire company. So how do you fundamentally change how you are deploying every single service at a company without incidents, without interrupting product development, and ultimately without interrupting our customers? Right? That's a huge problem to solve. Well, our solution was to have a larger project with more teams, which sounds great on a slide, but you run into very difficult management challenges when all of a sudden you go from a small group of folks in a CCOE, plus our AWS professional services partners, to now 20 plus teams across the company who are all migrating the orchestration layer of all their services. So what did we do? Well, underneath the action bullet point here, there are a couple things that we did internally from a management side to keep this project on track. The first one was weekly program check-ins. For those of you who are running large migrations, a weekly check-in is necessary to make sure you are addressing any blockers or other issues that are coming up with your services that are migrating. The second thing was weekly senior management check-ins. What we did during these meetings was actually highlight the wins of the teams, not only ourselves and AWS professional services, but our other internal teams as well, and basically give shout outs where we could, because we wanted to make this a celebratory event as we were changing the orchestration layer. The third thing was team assignments. We had folks from AWS professional services, we had full-time employees from our CCOE team. We put the two together and said, let's be stateful about the way that we are working and send individual pods out into the company with basically an alignment to a VP. So everyone under that VP's organization had the same full-time employee from Coinbase and the same folks from AWS professional services to migrate all their services. This allowed us to build domain expertise and trust. The next thing was automated reporting, all right? When you're doing a big project, you need to have stuff as automated as possible. So we brought in basically automation of our workforce. For those of you who use Jira, we use Jira. We use Jira tickets, right? So looking at our burn down charts to make sure that we were actually staffing appropriately and keeping on schedule. And we also had a script that we ran that estimated the amount of savings we were getting as we switched from EC2 to EKS. So when a team was switching the orchestration layer, after they were done, we would basically just run a script and say, hey, you saved X amount of money. And they got to put that as a win, right, for their team. And we looked at next week's objectives. We were on a week-by-week cadence with a massive migration. And so we were literally looking, on a Wednesday, what do we have scheduled for Monday? What do we have scheduled, for that next week? Where are we? Is the team bought in? Are we blocked by anything? And so that weekly check-in really helped us show up the next week with work to do and knowing the teams were on board. So let's talk about delivering on ROI. One of the important things you have to do in business is deliver on ROI, right? And so we had financial payback goals that we had to hit. The first of these was we identified higher ROI based on our migrations. So we basically said, okay, how can we take a service that is less optimal and move it over to EKS where it is optimal? And can we do the big ones first, right? The highest ROI first. Because then you prove that you are getting ROI, which again makes senior management and finance happy. Second thing was bin packing of services. When you have a single service on an EC2 node, and then you go to bin packing, right, you get a immediate ROI. And so we were able to measure that and share that with our management. The next thing was faster scaling. If you can go from a smaller fleet to a larger fleet faster, you can save money because you don't need to run that large fleet all the time. This sounds fairly obvious, but it's very difficult to do in a volatile environment. And so we were also able to count the savings that we got by scaling better. And the last thing was using Amazon EKS. Now look, we're here at reInvent, we all like Amazon services, but one of the big things that we discovered, and everyone else has probably found this with managed services, is that if you leave the undifferentiated heavy lifting to Amazon, you can go focus on what you're good at. So for instance, we have to do less in the control plane for EKS now. So what did we deliver? This is the big thing, all right? In 12 months, we migrated 3,500 service configurations, right? That's like the entirety of Coinbase moved orchestration layer. And again, thanks to AWS Professional Services for a lot of the heavy lifting that they did as we started migrating. All right, do you think you got this one?
So how do we begin preparing for this EKS migration powered by AWS Professional Services? Well, first and most importantly, we had to enable automation using an internal tool called kubetools. This was an internally built tool, and with a couple CLI commands, you can very easily create an EKS configuration based off your auto-scaling group configuration. There was sometimes some minor changes you needed to make, but this streamlining allowed us to really horizontally scale this workload a lot easier than, just a lot easier. Next, we implemented a mechanism to be able to load test our Kubernetes pods while we still had auto-scaling groups serving customer traffic. That allowed our builders to continually iterate with the service teams to make sure that whatever load those pods were seeing, we could handle that before we switch production traffic, because we always want to be able to serve our customers' traffic irrelevant of what is going on in the market. So we also actually began these migrations with just a single CCOE engineer, myself. Based off of these initial learnings, we created guides that we started sharing amongst our professional services engineers and the rest of the company as well to help them understand how to do this migration and if there's any tips and tricks that could help them along the process. And finally, we created a target list of in-scope services that were going to be worked on a weekly basis. The reason we wanted this tracking mechanism rather for these services is so we could celebrate these wins as we achieve them. That is how you build velocity. You celebrate amongst your team the work that has been done, the savings that have been achieved, and then you focus on the next goal, and then you celebrate that one as well. So what were some of the learnings from this migration? Well, first and most importantly, every migration will have some prerequisites. It would generally be helpful to de-risk these prerequisites as much as possible. We identified our classic load balancers to application load balancers as a potentially risky migration. As a result, we implemented automation to simplify this for our engineers, whether it was a Coinbase engineer making these changes or whether it is one of our builders doing the changes. We wanted to de-risk them as much as possible. Next, you want to use these complex migrations as a teaching moment. Instead of allowing your builders to spin their wheels just trying to figure this out, leave that to the tech lead of the project. Then, once the tech lead has done the migration and figured out what the issues were, share them during those daily sessions alongside any blockers the team may be having. That way, you can, again, build the internal knowledge so next time they encounter this, anyone on the team can handle it instead of just the tech lead. So as we previously tested, or as you probably have guessed, we load test very frequently in our environments. So we can uncover the unknowns or the risks before they impact our customers' traffic. One thing we learned very quickly as part of this migration is that IP space matters. We went from a platform where we had one host per service, one host per service, to one where you can have multiple services or multiple pods inside a single host. As a result, you're generally going to have more pods than you had EC2 instances. As a result, you'll use more IPs. The chart on the right side shows one of our accounts during a load test and running out of IPs. But luckily for us, we were able to identify that quickly and rectify it. But this is one thing to keep in mind if you're going for a similar migration. You need to look at every part of your infrastructure and anticipate where you're going to run into roadblocks. If you can't do that, definitely load test. So now we're at the end of this EKS migration push. What were some of the results of this? Well, for efficiency, we can now bin packer services since we're running a containerized compute platform. This allows savings since now we have multiple services on a single node. Furthermore, you can now be very granular with your resource requests. Beforehand, we could have a polar, and the smallest instance type we could go is, let's say, T4G large. Well, there's already too many cores on there. But now we can say, I only need a quarter of a core for this minor service, and we can provide that to our customers. As a result, we saw about a 68% reduction in our resources for migrated services to EKS. Next was scalability. With EKS, you don't need to wait for a new host to come online for you to have a pod running on it. This allows for much faster scale out since you don't have to worry about the initialization of that EC2 instance. With auto-scaling groups, each service would specify the overscaling buffer. So let's say you wanted to be sure that you can handle a 2x increase in traffic suddenly. You'll set your CPU to 45, 40, and then have the rest as a buffer. That is not efficient since each service sets that for themselves. But now with EKS, we can centrally set that scaling buffer in the cluster, and any service can use it, which makes it a lot more efficient for our infrastructure. All of this resulted in about a 50% increase in our scaling speeds, which again, in a volatile market, it is extremely important. And finally, centralization. Did my mic go off? Okay. Yeah, do you mind if I just take your mic?
Yep.
Sorry.
Excuse me. Oh, buttons have to get undone.
Thank you. Sorry about that. Just a minor step 5.
Yes, but we have HA.
And finally, centralization. So one of the reasons we decided to go with EKS is because it's a managed offering. We wanted to leave the undifferentiated heavy lifting to AWS. And as a result of this, we had reduced operational burden for our infrastructure teams. And next, you're going to hear Link talk about our last phase of the 10X program, which was the Graviton EKS migration.
All right, thank you, T. Okay, so if you guys remember back in phase 1, the first statement of work we signed with AWS, we were moving from x86 to Graviton. So that was great. The second phase of our work was EC2 to EKS. Now you'll notice there's a parentheses x86 because we started backsliding in our Graviton adoption. We got such better bin packing and such better cloud usage by going to EKS that when we looked back and we basically said, hey, well, what happened to Graviton? We realized that we hadn't actually ever put the two work streams together. And so we got a third phase, and we got a new statement of work, and we put the two things together, and we saved even more money. So let me just kind of talk through a little bit of the problem and solution we had here, right? So EKS running on x86 is efficient, right? But we're the cloud center of excellence. We look at efficiency differently. When we think of efficiency, we think of, are we getting the best possible rates for this workload? And the answer is no, because Graviton is 20% cheaper list price, right? And so we said, well, let's combine EKS plus Graviton, because that is the most optimal way to run a workload. So our problem was, obviously, multi-architecture work is losing ground, and our solution was to put the two things together, which, again, sounds fairly obvious, but if you are in management, you know that let's merge two work streams. That doesn't work because the skills required for each individual work stream are different. Just because somebody knows how to run EKS doesn't mean they understand our build system to get a Graviton-compatible artifact built and deployed into EKS. And so what we had to do was actually restaff our AWS professional services team. And this is where professional services really shines, because we were able to work with the AWS professional services folks and say, okay, we need somebody who knows EKS and Graviton. And we actually got a couple of those folks internally on our team, and we were able to use them to now merge the two work streams together. Because separately, those two teams didn't have that combined skill set that we needed, nor did we necessarily have the number of people we needed in-house at Coinbase. And so professional services helped us out. All right, go ahead, T.
So how do we start with this Graviton EKS migration? Well, first, we took the Graviton migration guides that we had previously, and we just updated them for EKS. We're still making the same changes to the build pipeline. We just needed to update the testing procedures since now we're running an EKS. Then we assembled a new target list of services. For this, we actually used what we learned previously, and we just focused on Golang services since we knew the compatibility and performance was there, so the ROI was there for our builders. Then, instead of focusing on the largest services to move, we decided to switch our sprints to be cluster-based because we wanted to have as many wins as possible during this journey, because that is how you build velocity in your team. So you get them excited for the work that they're doing. You get them excited for the results that they're seeing. That's how you build this, and that's how you complete the migration. The next learning. So first and foremost, the Graviton EKS migrations were simpler than our EKS migrations. That allowed our AWS builders to quickly progress through the backlog and complete the majority of the clusters in our production environment to be multi-arch enabled. Second, we actually identified Cluster Autoscaler as a blocker for us safely increasing our Graviton usage within our production clusters. I'll touch upon this in more details in a later slide. So remember how we had just updated the build pipeline previously? Well, through this Graviton EKS migration, we identified that we had a monolithic style repo that with a single PR would actually generate over 400 artifacts. As you can imagine, that is not efficient. And when we did the migration, or attempted to do the migration for this repo, we found that build times were increasing again. And as I said previously, customer experience matters. So we had to fix this. So with the help of our AWS builders, we were able to resolve this by re-architecting the build pipeline once more and enabling parallel builds within a repo. The market data you see, so market data, market trade, and adapters Binance, those are all individual projects within the same repo. With this new architecture, now we can run all of these builds in parallel, thereby reducing the overall build time, so better customer experience. But now we can also limit the builds to just the parts that changed. Cost reduction right there. So we knew we needed to do this before we rolled out this Graviton migration for that service, and this is how we achieved that. So now let's get into the scaling challenges that I kind of hinted at earlier. As previously mentioned, Cluster Autoscaler was preventing us from fully utilizing the Graviton benefits across our fleet. That is because by default, Cluster Autoscaler will at random pick a node pool to scale out. There are some mechanisms to put priority, but the main limiter for us is we needed to have a way to have a preference for Graviton-based hosts while still having a fallback option in x86. Because again, we need to keep serving our customers traffic irrelevant of what's going on in the environment or with AWS. So to solve this, we actually just ended up increasing the amount of Graviton node pools within the cluster. That way, when Cluster Autoscaler randomly picked a node pool, it had a higher chance of picking a Graviton-based host than an x86 one. And with these changes, as you can see on the chart on the right-hand side, we're able to burst into Graviton while still having the fallback x86 option. And one thing to keep in mind, instance availability is better now than when Graviton was first launched, but you always want to have a backup because you never know what's going to happen. There could be other customers that use up all the instances, and then you can't scale out. So you always have to have the fallback option, and that's how we achieve that with EKS. So now we're at the end of the EKS to Graviton migration. What were some of the results? For efficiency, we're able to achieve about a 10% savings on our compute because of that 20% savings for the instances. On scalability, due to Graviton hosts being able to sustain a higher utilization while having better latency, each of these hosts actually provided us more buffer capacity as the services scaled up. Because as you know, if your service is operating at 90%, your latency is probably pretty bad, so you need to decrease it. So you always want to have that buffer capacity available. Next is resiliency. With the ability for us to have additional instance types, we had just better overall availability, thereby reducing operational issues for our teams. And now I'm going to hand it back to Link so we can cover some of the learnings from the 10X program.
Awesome. Thank you, G. Oh, 1 second, guys. Just quick water. OK, so let's talk about the learnings from 10X. One of the biggest things that we learned was return on investment matters, right? AWS professional services, the statement of work, they cost money. And so if you're going to invest money in hiring professional services, you have to show that your company got something for it. So return on investment, financially measured, was one of the things that we learned we had to do, right? That doesn't always come, obviously, to engineers, but the business does look at that. So what we did is we focused on high ROI programs. We defined high ROI programs in 3 ways. The first pillar was effort, right? How much work is it going to take to transform this service from where it is today to where we want it to be? The second thing is what are the cost savings we can get? If we do this transformation from where it is today to where we want it to be, are we going to save a lot of money or a little money? And the last thing is customer impact. If we mess up while we're changing it, how much are our customers impact? And what we identified was basically every single service we could put into a bucket, right? And so what we went after first was low effort, high ROI, low impact services. And the idea here was to show success, right? As you start to move services, and again, we moved 3,500 service configurations, you begin to recognize patterns. But the first time you do a service, you're establishing that pattern. So there's a higher likelihood you're going to mess up or miss a step. And by the time you're on high effort, low cost savings, high customer impact services, you want to be able to talk to that service owning team and say, we've done this pattern before, we know how this pattern works, and we have already messed up this pattern, and here's our plan A, B, and C if we see that happen in your service, right? So as we started to move services that are customer facing, what we call our tier 0 services, that are core customer journey around exchanging or trading, as we moved those services, because we were able to tell those teams, we've done this before, we know what we're doing, and we had very few impacts on customers. The next thing we did was we broke our journey into 3 distinct phases. Each phase, we were able to learn something and carry it forward into the next phase. So for instance, with Graviton, we realized that writing down what we were doing and producing guides was an incredibly helpful way to allow new AWS professional services folks to come on, read documentation, use scripts, and quickly get up to speed. Right? Rather than taking 2 months to bring a new engineer on board and up to speed, we could bring people on and have them producing in a month. The next thing we learned was, as we had high risk and high volume workloads, we kept some of the same core people from professional services around because they knew the high risk, high volume workloads that we were having that we had to move. And so they knew what needed to be done because it was different for those services. The next thing we did was we defined a clear single-threaded leader. When we got to moving all our services over to Kubernetes, we came up with a pod structure. And this pod structure basically said, okay, we have 20 or 30 folks from AWS professional services. At the time, CCO was about 5 people. We said, okay, well, 20 full-time or 20 AWS professional services folks, 5 full-time employees, you do the math. Every full-time employee gets 4 AWS professional services teammates. Right? And now we move forward. And what happened was, as any of those 4 folks got stuck, they were able to go to the full-time employee and say, I need help. Now, I need help with what? I need help with blockers, right? I have a technical problem. I need help with product team coordination. I want to do something. The product manager says we have to launch this new feature, and they're not letting me get into their sprint. Or the biggest thing we found was cultural onboarding, which is, I need to do this. I'm from AWS Professional Services. This service owner from Coinbase doesn't yet trust me enough. So how do you bridge the trust gap? Because you know what happens when you tell a service owning team to move a service? They say no, because what if something happens? I'm too busy. I've got other stuff already planned, right? So how do you overcome that cultural problem? And that's what we found by teaming up full-time employees with AWS Professional Services folks. We were able to overcome that cultural trust barrier. And actually over time, because this took us about 18 months to do, we actually found that some of the core AWS Professional Services folks were able to adapt and adopt Coinbase's culture. So they could start carrying forward that culture and making the case to do migrations themselves. That was a huge win for both companies. The last thing we learned was production deployment. AWS Professional Services does not touch production. But through our basically PR pull request controls and service owning teams giving the final sign-off, we were able to more seamlessly meld the work that AWS builders were providing all the way through our build pipeline and out into our production environments quickly. T.
So what were some of the results of the overall 10X program? Well, first, and most importantly, we're able to achieve a massive migration in the EKS in about a 12-month period. By utilizing EKS, we are now able to scale faster and scale more reliably to to make sure that our customer traffic is served as best as possible and improve our overall customer experience. Throughout all these phases, we're also able to prove that ROI-based funding works, which is extremely important. This is how we were able to fund this program, by showing that the work that we're doing is actually saving $1 for the company, or obviously more than $1. And throughout all these phases, we're actually able to achieve a pretty aggressive cost-saving goals due to the work with AWS Professional Services. And finally, our Cloud Center of Excellence team became the flexible workforce experts. I can't say how many times I've been contacted by various teams, again, to replicate this for them. And as you can imagine, this makes your team quite uniquely differentiated within your company and makes your team well known because of it.
Thank you all.